This is a video on alternating series. The problem we'll be doing is the summation from 1 to infinity of -1 to the n times 1 plus n over n squared. So what we need to do to find convergence for this is we will have to follow the three rules for the three conditions for convergence. So we'll write conditions. Condition 1 is that the limit as n approaches infinity of a sub n equals 0. So limit of n approaches infinity of a sub n equals 0. Rule 2, a sub n is greater than a sub n plus 1. And rule 3 is a sub n is greater than 0. So then we apply these this way. We take our problem. So for the first rule, we'll do the limit as n approaches infinity of just 1 plus n to the n squared. And we know by dominance that this is going to be 0 because the bottom, is, if it approaches infinity, it'll be 0. So we know that. So check for rule 1, right? Rule 2, we plug in, we'll do rule 3 next. We plug in, we just write out the series for the first few terms. So it'll be 2 over 1 plus 3 over 4 plus 5 over 4, and etc. And these are all positive, so that's a check. And then finally, we have to find rule 2, which is a sub n is greater than a sub n plus 1. So 1 plus n over n squared is greater than n plus 2 over n plus 1 squared. And then n plus 1 to the third is greater than n to the third plus 2n squared. And then finally we get n to the third plus 3n squared plus 3n plus 1 is greater than n to the third plus n squared. And then n to the third plus 3 n squared plus 3n plus 1 is greater than 0. So that checks. And so since we have all three conditions, this converges by the alternating series test.